one of the query, like, can we use multispectral image datasets from external sources for plant disease detection?
No, because we are not sure whether that's really a multispectral data set. Because we want to take this POC, go out in the field and check. And when we check, we want an end-to-end solution. We want a camera to be there. If you don't want to invest in a camera or a area sensor, please don't take up this challenge.
Yeah. So far, that's all as of for now. So we have received. It's not a query. Like, some people have asked, if it's possible, can you explain more about the object detection in extreme dark condition? So.
So question is like, are you able to detect object in an extreme dark condition? Answer is no, you will not be able to detect. Okay, so how are you going to do that?
Yeah.
So that's the challenge here, right?
Yes.
I mean, suggesting any method from my side will be actually detrimental for your investigation. You're supposed to come up with the methods.
Yeah.
Right. But we have to understand here that it has to have some imaging sensors. Imaging sensors means sensors that can give you perception of an object, that here is an object. It could be an ultrasound sensor, for example. Okay. Can ultrasound give a sensor sense of an object? Maybe yes, maybe no. Okay. Can you identify shape of an object? Could we use a LiDAR? Could we use a camera? Could we use infrared? These are the different choices you have to make. You can make a combination choice as well. If you use 2 or 3 sensors to detect the same object, remember you have to use fusion then. Okay.
Okay.
So that's why this is a complex challenge. We ensure that we bring here to TechGM complex challenges that we want to be solved. That's why we open such forums, right? And it will be fun for mutually for both the students and LTTS to enjoy the session, right?
Yes, sir.
So our challenges are not going to be simplistic that you can find on the internet. Our challenge is real, and these challenges, once we have POCs from your side, whether you win a prize or not, if you are selected, you'll be part of a bigger implementation team. So that's why these challenges. So don't refrain from investing in it. I encourage you investing some of it and doing it. Definitely, I think it will brighten your career wherever it is and increase your expertise in these fields. Yeah, but when it comes to object detection in the dark conditions, it's already available. So you can look at some of the current existing solutions. One good example is in the military applications. How is that being done? Okay, how do they identify the objects in the dark? So you can start with that point if you wanted. But finally, the perception of object, whatever it is, it'll be nice to understand what that object is also, right? If you say there is an object here or an obstacle here, that's not good enough, maybe, right? You have to identify the object also. So how do you identify it? So you can identify if you can get the features of the object. If you get the features of the object, you could probably train in using AI model, right? So choose sensor or methodology that can give you features of the object, not just the outline of the object, maybe some features of the object. You could also consider something like heat sensors, for example. So choices are yours. I mean, I would say every choice has its positives and negatives. So suppose the sensors that you choose are able to detect under dark conditions, but somehow what happens is that you're not able to detect any some negatives could be there. That's okay, but you have to basically demonstrate you are able to detect. So consider a 2 feet by 2 feet box, dark box, and place some objects and detect under dark conditions. Okay, and let those consider for some cars and some toys, for example, where you can key them and it starts moving. Try to detect them in motion. This is what you got to demonstrate. Okay, from the outside, you put a monitor and there you see the objects are moving here. I'm showing you here how they're moving, and I'm able to identify also. That's what we're looking for, that you have detected objects, you also identified which are those objects. Okay, that's about it.
Thank you, sir. So is it okay, can we take one last question and wind up the session, sir?
Yeah.
There's a question, like, in localizing object location, how the radar sensor will calculate the nearest vehicle while moving, or it will calculate the exact distance.
Localizing object detection, observing from camera and radars using fusion, right?
Yeah.
Yeah. So now from camera, if you put a front camera in front of a car or a vehicle, and I want to detect distance to the object, it is not possible from a front looking camera. Whatever we do will be kind of an estimation. But suppose I use a radar, okay, or I use an ultrasound sensor, or whatever it is, distance measuring sensor, even LiDAR is fine. But basically we are saying LiDAR. What happens? Uh, we are going to find the distance. Okay, one second.
Yeah.
One second. Hello, Anish, are we done?
Yes, sir. Actually, yes, it is. That's all. Actually, if it's possible, if it is okay, we'll just conclude with implementation on edge computing. What is it expected? So with this, we'll conclude.
Okay.
Yeah. Will it okay, sir, to answer or?
No, I didn't get the question, Anish.
So can you explain what has to be implemented in the edge computing system for object detection and alert generation?
Ah, okay. So we are expecting that you build a standalone system uh, that can be used for object detection and alert generation. That means an edge system, we are saying, right? Edge computing system is something it has got its own computing capabilities in terms of AI. Okay. For example, this kind of model is popular in surveillance. Let's say I want to detect people counting. We want to do people counting, or uh, we want to detect some suspicious activity. So we want to. You may have seen CCTV cameras. Imagine live stream camera streams coming in, and but we don't monitor anything. We just, maybe most of the ones that are there just detect motion. So here we are talking about computing on the edge. So computing at the edge means you are doing these computations of detecting objects and so on very near to the camera. So that means you are placing a small high performing computer like an edge computer. For example, could be NVIDIA Nano or a Intel Mirror GPU, or it could be some other. Choice is yours. It could be a small computer with a high capacity computing power, very closer to the computer. And as and when object is detected, you should be able to alert a remote system uh, by sending appropriate messages. Uh, you could use something like a REST protocol to send messages um, to a remote system. You can assume a client server model. For example, you can say that your edge system is like a server, which is detecting some objects, and from the client, there is some kind of polling where it's asking if there is any security incident happened, and then this edge computing server basically says, okay, I detected an object here. Let's say it could be an ATM. In front of the ATM, you're trying to detect, there could be some secure areas and unsecure areas in ATM. So if you detect an object behind an ATM, behind the ATM box, then that's suspicious activity, right? So these are the various places where we try to identify objects and we generate alerts, right? You don't normally generate alert whenever somebody comes into an office, right? Because that's normal, that's expected. But to do the surveillance of some restricted areas and to generate alerts on an object detection when it is not supposed to be detected on particular type of objects is what. If let us say into office reception area, a dog comes in, you'd like to alert somebody, right? So that's the point. So you could demonstrate that. But here, you have to build end-to-end system. That means you have to choose your camera, edge computing device, you have to demonstrate object detection, and then you also have to have a way that you can show that from a remote computer, I'm able to get the responses on a particular. So ideally, on the client, you can demonstrate another application which can show whenever an object detected, a response coming. That response example, you could send something like an XML message from the edge computing device, where the XML tags you can kind of populate with the type of the object detected, and image or incident when the object detected, with a bounding box with the object detected, some kind of info that the client device can basically keep a log of which object detected when, with timestamp also. So this is what we mean by an entire system.
Thank you, sir. So, thank you for your valuable time and with your patience and answering all the queries. Thank you, students as well. For
Yeah.
participating in the event and the live session. So